Welcome to Section 2 of this module, in which we shall discuss some important safety-related topics. Compressed air can be very dangerous, even though it feels safe. The pressure and speed of air leaving a nozzle can propel minute objects like small bullets that can easily penetrate the skin or an eye. The forces generated by power cylinders can easily crush a limb. Don't be fooled. Compressed air is dangerous. But ironically, most of the accidents related to air systems are caused by the innocent-looking shop air hose. So let's take a moment to discuss this. The shop air hose is used for all sorts of odd jobs, but most commonly for blowing dust or dirt from components during maintenance. The device used on the end of the hose is the air gun, also called a duster gun. This useful tool is commonly used to blast away the dirt and dust which collects in those hard-to-reach places. It must be appreciated that when we use the air gun, we are causing small, solid particles to fly about at considerable speed. These particles can easily strike a person and can penetrate the skin or an eye, as previously mentioned. So, the very first safety rule if you intend using an air gun, or when working on airline connections, is to make sure that you are wearing suitable eye protection. The next rule is that you always direct the nozzle of the gun away from your body. In this way, the moving particles will not strike you. You must also be aware that the blast can strike fellow workers, so be careful when others are working around you. Never, ever use the air gun to blow yourself down. This dangerous and foolish practice can cause serious injury, including blood poisoning owing to dirt entering your body through the skin. It follows that you should never play the fool with an air hose either. It is a punishable offense to deliberately aim the air hose at another person, or to place an air nozzle against that person. The shop air hose is most usually connected to a quick coupler. These useful connector points provide for quick and easy coupling into the air main or to a user point. The correct way to make a connection is to begin by shutting off the isolation valve and releasing the pressure from the line. If the line has a moisture trap, then the pressure can be drained by operating the drain valve. Next, pull back the connector sleeve and then insert the spigot. Push hard on the spigot to make sure that it fully enters the connector. Release the connector sleeve and then check that the connection has locked into place by gently pulling the spigot. The same process is made when connecting the working device to the opposite end of the hose. The isolation valve can now be switched back on, and the tool or working device is ready for action. Disconnection is as simple as connecting. Close the supply and release the pressure. Then push the spigot into the coupler and pull back the sleeve. Hold back on the sleeve and then pull out the spigot. If a line does not have an isolation valve, you will be forced to connect or disconnect a coupling against pressure. This requires some special care. Pull back the sleeve and then push the spigot firmly into the connector. You will now be forcing it against air pressure. Maintain the force upon the spigot and release the sleeve. It is recommended that you work from the side of the coupling, so that should the spigot shoot out, you will not be struck and possibly injured. When disconnecting, push in and hold the spigot firmly. Maintain a strong hold on the spigot and then pull back the sleeve. Remove the spigot and release the sleeve. Let us look now at the couplings used typically for heavy-duty equipment, which includes mobile compressors. This type of connection utilizes half couplings, so called because half of the coupling is attached to the shut-off valve and the other half is connected to the hose. Each half coupling contains a rubber sealing ring. These rings must be in good condition and free of dirt or dust before the hose can be connected. It is a legal requirement for a safety link to be fitted to connections using half couplings. This link is designed to prevent an accident in the event that the coupling halves should become detached whilst pressure is in the line. Connection is made as demonstrated using a twisting motion, making sure that the two interlocking shoulders fully engage. Both ends of the air line must be connected and made safe in the same manner. Only then is it permitted to open the shut-off valve to pressurize the line. Before disconnecting the air hose, always close the shut-off valve and depressurize the line by operating the working unit until the pressure runs out. Air hoses should be maintained in good order. Keep them clean by wiping them to remove any oil or grease that will damage the hose. Check that the end fittings are secure by checking the clamps where applicable. Inspect the hoses regularly for signs of damage, such as cracking and perishing. Replace damaged hoses with new sections. Use only genuine air hose, which is rated to hold the pressure generated by your air system. Roll up the hose and store it on a suitable hook or a shelf. Don't leave hoses lying about on the ground where dirt will collect in them. Let us turn our attention to safety on and around compressors. Some compressors, notably belt-driven types, have exposed moving parts. All moving parts must by law be covered, that is to say, guarded, to protect against accidental contact. A guard may not be removed unless the compressor has first been totally isolated from its main electrical supply. The same applies to rotary screw compressors. The cabinet doors, which act as guards, should only be opened or removed after the compressor has been shut down and isolated. Should the need arise to operate any machine without guards, then it is vital that you keep your hands well clear of rotating equipment. We shall conclude this module with some tips on good housekeeping. The suction effect on the intake side of most compressors is quite strong. Any rubbish, such as plastic and paper, must be removed from intakes to prevent a restriction in the flow of incoming air. Clean up any liquid spills around the compressor. This will reduce the risk of someone slipping and falling against machinery. For the sake of safety, compressors and related equipment should always be easily accessible. This brings us to the end of Module 1. In other modules in this series, you will learn the operating principles of compressors and how to perform routine maintenance tasks.